Hi, I'm Rich Seifert, and I have been the energy and housing guy for Cooperative Extension for many years. We all know that energy efficiency and energy costs are driving a lot of us into a situation of less money for the household. So today we're going to show you how to use insulation well, installing it either in a new situation or in retrofit. And we're going to go through some of the details and show you why it's important to attend to the details and in the order that we install them. And also we're going to show you how to make sure that you avoid leaks and voids, and how to make sure you have a good vapor seal when you're finished. So we've mocked up these walls as examples. We're going to fill them with insulation, and we're going to do several different types of insulation to show you some of the options you may have available to you if you do this work yourself. So let's get started. Now, you'll notice how annoying this material is. It's very fibrous, it gets in your lungs, it makes your nose itch, and I should be wearing a mask to do this, but I can't talk and wear the mask too very well. And you'll notice that I have a little knife here. It's best to use a fillet knife to fluff this out so that you have full coverage, and the entire stud cavity is filled right to the edge, right to the to the top and flush with insulation, so you don't get any voids. If you have voids, if you allow the insulation to be installed by someone who doesn't understand that this is an important feature and detail of the installation, you can end up with 10% of the voids area causing 50% heat loss increase just by only 10% of the cross-sectional area of this stud space being uncovered with insulation. So you want to make sure it's flush up at the top, flush down at the bottom, and fluffed out the entire distance of the stud cavity, so that when you put the vapor barrier on this, you cover it entirely and there's no voids for air leakage. So you're getting the full value of the installed thickness of the insulation. Okay, we have now put the wall section down on the floor and filled the rest of the stud spaces with insulation. This job is unpleasant because working with fiberglass is unpleasant, but it would be much easier to do it if you had cellulose insulation. And recently, cellulose insulation has become available most places. One of the problems in rural Alaska is that fiberglass is really much more expensive to get to rural Alaska because of the bulkage cost, and now it's getting better to get cellulose insulation there because it can be compacted, sent out in bales, and a machine can be used to inflate it, and it's much less aggravating. No caustic fibers that get in your lungs and make you cough like I am coughing, and it's a lot easier to work with consequently. So you could fill this entire cavity very easily with cellulose. We're now going to put the vapor barrier on and show you how to seal the vapor barrier to do a good job. Okay, we have prepared the wall section. We've made sure the insulation is fluffed up, and we're about to apply the vapor barrier. In this case, 6 mil polyethylene, also called visqueen. And we're going to do this with staples and with a material called Tremco acoustical sealant, which, if any of you have had experience with it, you know it's also called Black Death. We're going to show you how to apply it in a bead. Now, we don't need to put a bead on every stud space. We just need to make sure that when we're done, we have a fairly impermeable, permanently affixed, caulked and sealed top plate, bottom plate and several different wall studs, such that it is an intact air seal and vapor seal for the wall system, so that no moisture gets into the wall section, or very little gets in there after we're finished with it. And Art's going to apply this, and we'll show you how to compress the seal to make the application of Tremco acoustical sealant as least messy as possible, because it's called Black Death because it's so tenacious and sticky. We'll show you what that means. And it's so tenacious and sticky because it never hardens and therefore makes a permanent seal, which seals vapor out of the wall. So let's begin to do that. Okay, we have cut the edge of the tube, which is the tube which the caulk comes out of, the Tremco acoustical sealant, and we cut it about a 45-degree angle. We want it to be about a pen width in size so that it lays a good bead, not too wide. We don't want it to just mess up the whole face of the stud, but we'll just lay down a bead and then we'll eventually smooth it out under the caulking material and staple through it. So let's start laying it down and see what it looks like. Okay, good so far, yep. That's getting better because that's a perfect thickness just about. You got a little stop there. Okay. By the way, they do make a hydraulic caulking guns, which is the fast but lazy way to do it well. Most of us will have a hand caulking gun like Art has, and he's doing a really good job. And you will notice immediately when this happens that it's really good to have two men on the job. Oh, you're going to go that way. Okay. Good job. If ever there was a job that needs to be done carefully, it's this one. Okay, now let's lay this on to both edges, and then we'll staple both edges. So let me get down here, lay this over. Is that enough over there? Okay. Well, I've got it down. Why don't you start here? Okay. You want to push this and smooth the bead so that you can easily see it through the poly, and then you always try and staple through the bead of caulk, through the poly, through the bead of caulk, so that it's self-sealing. And every 6 inches is a good spacing, not 100 per stud or anything like that. Good job. Well, we're only trying to adhere to keep the polyethylene in place because ultimately we're going to put some kind of interior finish. Typically it's gyprock on this wall, and that will be screwed in place with sheetrock screws, and that will help compress the bead of caulk and compress the poly against the bead of caulk, and will even further seal it and compress it. So the staples are merely to hold the polyethylene in position until the final finish comes. We're fortunate enough today to be at the Cold Climate Housing Research Center in Fairbanks, where they have done a mock-up of one of their recommended wall systems, which is the remote wall. And it's a really, really wonderful example because it's essentially a wall that starts with a 2x4 stud framing for the structural wall. It has a two top plate, double top plate wall system for loading. And we'll look at the inside later, but all the insulation is beyond a vapor barrier made of, well, it can be many things, but in this case, the vapor barrier on this wall is bituthane with a fiber surface. And the way the wall is extended with this jamb is also important for retrofit, because when you add insulation to the outside, you have to extend the jambs of the windows to accommodate the increased depth of the wall. Same with the doors, and it's not easy, and it's a lot of extra work, but this shows a very elegant example of how to do that. And flashing around that window, especially in places like rural Alaska, western Alaska, the Aleutians, southeast, where you have a lot of horizontal rain, you want to make sure the window is flashed well to prevent leakage. This uses a material that Tyvek makes with bituthane backing that's formable, and all the drainage plane to make sure this window opening doesn't leak is like wearing a raincoat on the outside of everything, so everything sheds out. This laps over this edge piece laps over the bottom piece. Everything is made to drain out and so that it doesn't leak. It's very well sealed. And then you can see that the insulation is 2.5 inch thick pieces of styrofoam with foil backing, actually. You can't see it very well. You can see it on the other end. We'll show it later. But, and then framed out with lath so that you can put siding on it, and a corner with fiberglass framing to make it structurally sound. You can see the foil face over on that corner, and of course this window is cut away and cut away here for your view. Obviously we don't want to finish the window with that kind of hole in it. But let's look at the inside now, because the inside, extra insulation. You could view this as a standard 2x4 stud wall that has fiberglass in it. You would have to really fill these corners with fiberglass, cut and fit that, because the corners are difficult to insulate. They always are. They have a lot of wood in them. And let's look more carefully at the inside of the window. You can see the flashing, the pan flashing here to keep the window draining to the outside. You would want to put a little foam in here to insulate the window, a rough opening, and seal it so that it doesn't leak. There need to be a little more insulation in here. You could actually fill this with or build it with a piece of SIPS panel, and we'll show you some of that later on. And here is just another piece of fiberglass on the inside of the framing of the standard wood wall, which is used as the base load-bearing wall for this system. So there you have it. I have some really good examples here of structural insulated panel materials. This particular set of materials, except for this, which is a TJI, and I'll talk about that later, are from Emercor, which is a company in Canada, but it shows you all the various opportunities you have to use structural insulated panels, and it's a material that is really, really common and well advised to be used in rural Alaska if you can get the materials to you from a transportation point of view. This is the way the structural insulated panels fit together if there's a wall or floor system or even a roof system. The panel itself is 2.5 inches, 2 7/16 inches thick, has R14 even though it has that much insulation. These panels that you see here, these sections of panels are all insulated with polyurethane foam. So they have very high R value per inch. There are other systems of panels, and there are many commercially made, that use styrofoam, beadboard styrofoam, white beadboard, instead of polyurethane, which has less of an R value per inch. So the thickness is very much more crucial there. The thicker they are, the more insulation there is. But these are very, very thin for a very high R value of insulation. For instance, here's one that has a sheetrock on one side and paper on the other. It's only 3¼ inches thick, but has an R value of 20. It could be used, for instance, to glue as an interior retrofit to the inside of a wall. And the example of the materials, qualities, and dimensions and whatever are all listed right there. There's another set here which has OSB on one side and plywood on the other. It's 4.5 inches thick, R28. Remarkable. About R7 per inch, which is a typical amount for fresh urethane foam undamaged. Here's one with OSB on both sides. This is a pretty standard design for a SIPS panel. And you can see the OSB there, and on side view what it looks like. Not quite plywood. Never has been, never will be. But I don't know if I'll ever get these back together the way they came in the panels. But I also, like I said, I wanted to talk about this material. This is a beautiful example of a, it's called silent floor. Truss Joist Macmillan makes it. It's a common jargon calls it a TJI. That's because it was originally made by a company named Truss Joist Incorporated, now made by a collaboration of two companies, Truss Joist and Macmillan Plywood, Canadian company. OSB webbing, top and bottom cord for the material. This is essentially a plywood I-beam, made to take the place, in this case, of dimensionally a 2x10. This dimension, 10 inches apart, same width, 1.5 inches, but top and bottom are very deep plywood material. Very structurally rigid. It comes into lengths of 40 feet. You can structurally compare this to a 2x10, but it weighs a whole lot less. It's actually a material that we have engineered to take the place of a 2x10, and it's a very, very good material for rural Alaska. If you can protect it from getting wet in transport, comes straight, comes length of 40 feet. You can't do anything like that with a 2x10. Wonderful material if you can get it, and highly recommended. Can fill a space with insulation, can be used for floors, for roofs, and has a lot of alternatives. And finally, a very thick structural insulated panel system with all-weather plywood on the exterior, OSB on the interior, 6.5 inches R44. Really, really excellent way to build a building with a water-resistant, rot-proof exterior, plywood interior, structurally rigid, and extremely super insulated. R44 wall insulation, can't do any better than that. Solid and very continuous, no voids. Because we're here at the Cold Climate Housing Research Center, we have a unique opportunity to use their demonstration wall to show you a really good detail on how to apply foam caulk around a rough opening in a window. And we also recommend you use non-expanding foam caulk. But if you come in close here, because this window is cut away, it allows us to see this area right here between the rough opening and the window, and it goes all the way to the outside edge. And I'll back away now, and Art will come in and show you. We want to, when you spray caulk in there, you want to put the hose of the caulk, the nose of the caulk gun, all the way to the outside and spray the bead in there. We're not going to actually do it because this isn't our window and we won't want to do it. But that's how you would spray it and let it, for about 30 seconds, expand to its final finish, get skinned over, and then you might want to come back and do another bead a second time and fill some of that space. You can also use backer rod, which is a material, a tubular caulk, to fill some of that space, and then spray the caulk bead against it. It helps you not use as much of the plastic foam as you otherwise would. Well, now that we've shown you how to use the caulk in a rough opening to seal around a window or a door opening, let's just take a little foam bead of it, watch it expand, show how it comes out of the tube, and see how long it takes to reach its final dimensions. Probably should wait about 30 seconds. It doesn't seem to be moving very much, and that's good. Very low expansion foam. It should skin over. It'll remain soft for a long while. This is only a few minutes after we've sprayed, and the instructions on the can say that the foam will skin over, will actually cure dryad attack after 30 minutes. So it takes a long while for it to cure up, but you can see that it's much smoother, slightly larger than it was when we sprayed it, but it won't get tack-free until 30 minutes after you install it. There are two more things I want to say about the foam. First of all, you should fill the foam to about 1/3 of the depth of the opening, and it should cure up very nicely. The second thing is that if you do overfill it, you can actually come back with a utility knife and trim it back to flush with the edge of the window and make a neat detail out of it. So it's not a big problem. The other thing to be concerned about is if, for instance, in the case of an accident where you actually spill it on a piece of plastic or a piece of wood, you should wipe it up immediately because it's extremely adhesive if you let it dry. And so you want to clean it up and keep a rag handy just like you do for Tremco in case you get it on something that you don't want it to be on.